Newton's third law states that for every action, there is an equal and opposite reaction. The action force and the reaction force are equal in magnitude. The action force and the reaction force are opposite in direction. These forces act on different objects. They do not cancel each other out. This principle applies universally, from simple pushes to complex interactions. When a force is applied to an object, that object exerts an equal and opposite force in return. Even if an object does not visibly move, it still exerts a reaction force. The action and reaction forces are equal in magnitude and opposite in direction. This principle applies regardless of whether the object moves or remains stationary. The reaction force is a fundamental aspect of force interactions. Understanding reaction forces is crucial for analyzing physical systems. Newton's third law of motion states that for every action, there is an equal and opposite reaction. In a rocket launch, the action is the expulsion of gas downwards. The reaction in a rocket launch is the gas pushing the rocket upwards with equal force. Similarly, a swimmer's action of pushing against the water results in the water pushing them forward. When a force is applied to a wall, action, the wall exerts an equal and opposite force, reaction. The force exerted on the wall is equal in magnitude to the force exerted back. The forces act in opposite directions, resulting in a balanced interaction. This interaction demonstrates Newton's third law of motion. The pushback experienced is a direct result of the wall's reaction force. When an object exerts a force on the ground, action, the ground exerts an equal and opposite force back on the object, reaction. The reaction force from the ground allows the object to remain stationary without falling. When an object jumps, it exerts a greater downward force on the ground. The ground reacts by exerting an equal and opposite upward force, propelling the object into the air. A rocket expels hot gases downward, representing the action force. The expelled gases exert an equal and opposite force upward on the rocket, representing the reaction force. The reaction force propels the rocket forward through space. A swimmer pushes water backward with their hands and feet, representing the action force. The water exerts an equal and opposite force forward on the swimmer, representing the reaction force. The reaction force enables the swimmer to move forward through the water,